clock for 6 minutes. I'm going to give you kind of a more extended amount of time to work on this today. And I'm going to walk around in a second and check to make sure we have calculators, which we'll need to solve this. And just kind of peek over your shoulder to see who's got it and who's kind of struggling with this. All you're doing is solving for the missing side length x. So you need to set up using SOHCAHTOA, sine, cosine, tangent, or one of the other three with your ratio and solve for x, okay? Try that out while I take attendance. All right, Israel, Felix, Edith, Eli,
Here.
Dahlia, Stephanie, Diego, Jamie Lynn, Sandy, Brandon, Brian, Juan Carlos, Martin, Nen, Kennedy, Giselle, Leo, Gustavo, Lirio, Tyler, Melanie, Lazaro, Jonathan, Messiah,
He's absent.
Kevin,
Here.
or Joanna, is she here?
No.
Eham, Christina, Johnny, Luis, Deanthea, Brian. He's here. Okay.
You get them until Friday.
Yeah, they should. And then I'm going to pass around the inbox. Did you already use? For you to put any problem sets in that. Problem sets in here. Problem sets in here. Problem sets. Yay, so much grading tonight. Yay. Oh, you can blow it. Lyra's like, Lyra just watched. Wait, that's not your notes, that's your homework. Uh-oh. Switch. Alright, I'm going to come around and kind of see how we've started on this. You've got left 3 minutes, so you've used half of your time on this do first. You should definitely be through at least one of these.
Bless you.
Thanks.
If you're really pacing yourself, you've done with about half of them, but at least one. Should not be still staring at the triangle without starting. Okay, so let me come around and kind of see where we're at. Make sure we have our calculators. Good. Scary calculator. Good. Cosine? Cosine of 24 equals adjacent cosine of 24 equals cosine of 24 equals adjacent, which is 16 over x, and then here's solve for x. So you've got, these are good labels, but we don't care that much about the opposite side. We care about this one because it's what we need, and this one because it's what we have. So we've got adjacent and hypotenuse. Which one of them? Cosine. So you can say cosine of 24 degrees equals 16 16 over x. So start writing that. Cosine of 24 degrees equals adjacent to 16 over hypotenuse x. And then multiply the 16. Calculator, Jonathan? Okay. Oh. Did you solve any of them? What do you mean? So you had it set up. Cosine of 24 equals 16 over x. Okay, then multiply into x. And then you bracket x times cosine of 24 equals 16. And divide by cosine of 24. So you can solve for x. Now you just have x equals 16 divided by cosine of 24. Okay, let's see where we're at with some of these. We're only going to talk about and actually show the work for one. The rest we're just going to check the answers. You're going to notice I'm going to be giving you kind of like this, like 6 minutes of solid work time on the do first. I'm going to talk about in a second kind of a deal I'm going to have with y'all to make sure that we're actually getting started with a greater sense of urgency, like right when we come in here rather than just staring at our work. So, starting with the first one, this is the only one we're going to really talk about. Raise your hand if you can tell me which trig function you chose to use for this one right here. Sine, cosine, tangent, cosecant, secant, cotangent. Eli, what do you think? Cool. Cosine of 24 degrees. Remember, sine, cosine, tangent are always of an angle, which it gives us our angle, 24 degrees. And that's equal to a ratio of the adjacent over the hypotenuse. What's our adjacent, Eli?
16.
And our hypotenuse?
X.
X. And then we can multiply times x. And then divide by cosine of 24 degrees to solve for x. Sorry, my handwriting's messy. And x should equal 16 divided by cosine of 24 degrees in your calculator, which I believe would have been 17.514. Raise your hand if you have a different trig function. There's one other one that we could have used other than cosine. Let's recap from Friday. There you go. Secant of 24 degrees, because secant is the reciprocal. Instead of a over h, it's h over a. So you'd have x over 16. If you multiply times 16, you should get the same number, 17.514 for that. Okay? So that's a quick recap of the steps for the other problems. I'm just going to show you the numbers. You can check off any that you did. Any that you don't get to, if you want to jot down answers, then you can spend some time later practicing these if you feel like you weren't sure how to get started. Okay, so here we go. Next one was 22.172, then 7.507, then 3.216, 71.193, and last 4.096. So notice for all of those, you were given an angle and a side, and you were solving for another missing side, okay? Using any of the 6 trig functions that we went over on Friday. Today, we're going to still be solving right triangles, except we're going to start to get to not just solving for sides, but also solving for some of the angles on the inside, which we didn't really do yet on Friday. Okay, so a few things about what's to come with dealing with making sure we stay super focused on our do first, and talking about our problem set that you got from the blue folder. Okay, so you got a problem set from the blue folder. This problem set has a lot of this type of practice on it. So I'm going to make a deal with you, because if you think about the due date of this problem set, because its problem sets are usually due for me weekly on Monday, right? but Monday is like in Thanksgiving, and so it would have to be the Monday after Thanksgiving. And some people have been asking like, oh my gosh, homework over break. I'm one of those people that like doesn't do it until the weekend, which means I'm gonna have to be dealing with it over break, like 2 weeks from now, or Monday when we come back, and that's gonna be really awkward too. Because of all that, I'm gonna make a deal with y'all. This Monday, the 27th, is kind of a tentative due date. I'm hoping that right now I'm gonna actually say that all of us automatically have a 10 on this problem set, and I'm giving it more to you as like an option of practice on all of this triangle stuff if you feel like you need the support, but you do not have to complete it. However, that is with the caveat or the restriction that we have to make sure that we're super focused and maximizing the time that we are in here, which means I want us to work on like the goal of coming in here and getting started quicker on our do first and using that practice time, because we tend to waste like the first 5 minutes just kind of like walking around in here before we get really, really focused, okay? So similar to today, I'm going to be setting my timer. I need in the first 2 minutes, 100% of us to be like focused and trying something on the do first every day. You'll get 2 strikes. If I don't see that happen twice, then this will go back to a normal problem set, okay? But if you can keep it under 2 strikes, then this will just be a 10 problem set freebie that you can use as optional practice. Cool? Does that make sense? Okay? So tomorrow when you come in here, like calculators out, notes out, getting started ASAP in the first 2 minutes. Cool? Okay. For the whole week, you got 2 strikes. Okay? So I need, all I'm asking for is 5 days of like focus, do first, so we can get back in the habit of that, because we just, as the year has gone on, have gotten like slower and slower as we come in here. Okay? Cool. All right. So today, let's continue solving right triangles, except focusing a little bit more on the missing sides and the missing angles of right triangles. So let's talk about these things we call inverse sine, inverse cosine, and inverse tangent. We didn't talk about these ones on Friday. Let me talk about what we did do on Friday to kind of help introduce this. So we took right triangles like this guy. Let's say this triangle is 3, 4, 5, or the sides, okay? If you want to draw this, you can. If you'd rather just watch, in a second we're going to be writing some things down in this box. We said things like this, and you'll see stuff like this on your problem set. I'll ask for example, the sine of theta. All you can tell me is just the ratio from this triangle that is equal to sine of theta. Raise your hand. You can tell me for this triangle right here, what would sine of theta be equal to? What over what, Diego?
3 over...
Not quite. Looking at. You're good. Which one over 5? Keep going. Well, what is sine? Let's break it down a little bit. What over what before you get to the numbers?
Oh,
Sine is adjacent and opposite. What is it?
it's opposite.
Good. Opposite over hypotenuse. So let's look. Opposite of theta is what?
Okay, it's 4 over 5.
4 over 5.
Yeah,
Good.
I keep, yeah.
No, you just gave me the adjacent. You're good. So sine would be 4 over 5. Agreed? Yeah. Okay. So we just talked about the relationship here, the ratio. Then we took that and I said, okay, if I give you theta, for example, on the do first, we looked at cosine of 24 degrees is 16 over x, I think. Okay. In these problems, this x that was missing was what part of our triangle? A side or an angle? A side. We were missing a side, and we knew how to solve for that. In this, what's the only thing that's missing? An angle. So what we're going to talk about today is, okay, how do I solve for angle? If I want theta equals something, how can I get this to get that theta that's on the inside, like to the outside, and say theta equals something, okay? Now let's think about that. We've learned about something called the inverse in Unit 1, and then we looked at it again in Unit 3 when we looked at logs. If we're finding the inverse of something, can someone remind me what we switch when we're finding an inverse function? Do you have an idea? We switch x and y, like our input and our output, our independent and our dependent, we switch, right? We did that with logs as well. We switch our independent and our dependent, or our x and our y, which means we're going to take the inverse sine of not the angle, but of the side lengths, which is like our y from before, right? And that should be equal to our input, our theta, our like x, or our theta that's on the inside. So today we're going to use inverse sine rather than sine to switch these and put the side lengths on the inside and be solving for the angle on the outside. Okay? Cool? Okay, so let's talk about sine, cosine, tangent, and really quick write down kind of like these definitions. So for inverse sine, we just talked about because sine of theta, like regular sine of theta, is always opposite over hypotenuse. Then we know if we switch our independent and dependent, then that's inverse sine, not sim, sine. So inverse sine with this little -1 right here, that's how we say inverse sine, of O over H, our side lengths should be equal to theta. That's how we can solve for theta, our angle. Okay? If I know that cosine of theta is my adjacent over my hypotenuse, then I can find my angle by doing inverse cosine of adjacent over hypotenuse. That should give me my theta. And I know some of y'all noticed on Friday when you were pulling up sine and cosine, people saw that sine inverse, that little -1, and they were like, can I use that one? And I was like, no, we're going to learn about that next week. That's because that would have given us the angle and would have assumed that what you plugged in was the side. Okay? So if you're solving for the angle, you're going to use the inverse. If we're solving for the sides, we're going to use regular sine, cosine, tangent. Okay, and last step. Because tangent of theta is what over what?
Opposite over adjacent.
Good. Then you should be able right now, following the pattern, to fill this out, but then inverse tangent of O over A should be equal to theta. I'll give you about 5 more seconds to make sure you have those. Okay, now this is different. I want to point something out that some people have been kind of like crossing. Inverse sine, inverse cosine, inverse tangent are not the same as cosecant, secant, and cotangent. Because like inverse sine goes with sine, sometimes people get confused because on Friday we talked about how cosecant is like the opposite of sine. Except let's clarify what cosecant is. Cosecant, I'm not switching theta and O over H, right? Like theta is still here. Does anyone remember what the difference between cosecant and sine was? What's the difference there? These are not the same. Sandy?
We put the numerator and the denominator.
It's the reciprocal function, which means I'm just switching the ratio from O over H to H over O. So notice, inverse sine, I switched theta and O over H. Cosecant, I switched O and H. I didn't touch theta. Okay? So the reciprocal functions are these. The inverse functions are these. Those are different. Cool? Okay. Now that we've got the reciprocal functions, the inverse functions, the regular functions, we can use all these to find any angles or to find any side lengths. We should be able to do all of this now. So let's go ahead and look at solving for angles first. Then we'll put it all together. We're going to do one of these, then y'all are going to do the other two. So you got a triangle. It says find or use the trigonometric functions to find the measure of theta, round to the nearest 1,000th degree if necessary. So I look at this triangle and I notice I have 11 and 26. 11 and 26 are sides of my triangle. And I want to find theta, this angle. So already in my mind, because of what we learned today, I'm thinking, ooh, I'm solving for theta. That's an angle, which means I need to find an inverse trig function to use rather than like a regular trig function, because I'm solving for theta. So if I have this theta, 26, one would be my what related to theta? Opposite, adjacent, or hypotenuse? Opposite. 11 would be my what? Adjacent. So if I have O and A, my opposite and my adjacent, everyone go ahead and think in their head of what trig function that would be. Johnny, you got the trig function? Tangent. And because we're solving for theta, not regular tangent, but what? Inverse tangent plug in opposite over adjacent. Opposite is 26 over adjacent is 11, and that will be equal to theta, which is what we're solving for. Okay, so now go ahead and find inverse tangent on your calculator. If you go to the trig menu, inverse tan will be in there just like regular tangent was. So go ahead and find it, plug that in, see what you get. Raise your hand when you got it. 1, 2, 3, 4, 5 people, 6 people. Brian, what'd you get? Cool, and then everyone write degrees on that, either in words or the little degree symbol. If we're solving for an angle, I want units. And if your calculator's in degree mode, then it's going to give you an answer that's in degrees, okay? Okay, if you haven't already started, go ahead and try the next two. I'll be walking around to check. You don't have to. So because he has those two sides, he can use adjacent and hypotenuse. I mean, you can find this if you want, and then you could use this side, and you should get the same thing. But then you have to do 2 steps because you have to find the side length and then do the inverse to find this. But you can use any 2 side lengths to find it. You just have to find the right relationship. And if this is theta, then do you agree 5 is adjacent? And 12 is your hypotenuse. Adjacent and hypotenuse is cosine.
Because it is
Okay,
opposite.
but you found 119. So you were doing opposite.
Because
Okay, so you were doing inverse sine.
sine.
You should do the same thing when you put this on your sheet. You're gonna see in a second, like, so we're about to do some triangles where you can go, depending on what angle you look at and what angle Martin looks like, you could all have used different strategies, but we should just use the same answer.
Root 14 over 16.
You get the same thing as him. Same thing. Cool. Got him? Got all 3? All good? Got all 3? Nice. Got him? Okay. Can you put degrees on all of them and then fast? Okay, eyes up here. Someone really quick, so that we can move on. Give me the second one, just in case I didn't get to check your paper. There's like 100% of y'all that have it, so I just do lots of hands. It's an easy participation point. Felix. Degrees, perfect. And who I haven't heard from yet today, Jonathan.
65.376 degrees.
Cool. Okay. Okay. Now let's move on. So flip to the next page. Okay. Really quick, if I can get 100% of y'all to just put down your pencil really quickly and calculator or anything you're messing with. Kennedy, that's you. Christina, that's you. Put down your pencil eyes up here. I want to make a quick announcement about this problem that I know a lot of y'all are like, I got this. I'm just going to solve it. I'm going to ignore you, crazy lady. But I want you listening with me. So calculators down, eyes up here. I'm going to wait till I have 100% of y'all. Okay. I'm going to make the request of you for this next, minute or 2 for you to please stick with me rather than moving ahead, because for this problem, part of it is the answer, and I know almost 100% of you guys are doing really well with this and you can get to the answer, and that's awesome. But what I worry about more than the answer is, can you identify other people's strategies of how to solve these? These are the coolest problems because you can look at these 100 different ways with different strategies, looking at different sides and different angles, and get to the same answer. But you have to be able to understand other people's strategies. We love for these problems to show you someone else's work. You know those problems on the unit exam where it's like, did this person make a mistake, or could I use this strategy? Y'all have to have the higher level skill being able to find the answers like down here, and that's cool and all, but I want you to be able to build that higher level skill of seeing if someone else's strategy works, okay? So we're gonna go through this one problem, and then I promise I'm gonna let you practice one problem where I'm gonna ask for not just one way to solve it, but I want you to think of not one way, but another way that if someone else could have solved it for these, okay? For these problems, you need to find anything from the triangle that's missing. Triangles have how many sides?
3.
How many angles? 3. 3 sides, 3 angles. For this first one, notice I only am given one side, and then I'm given 2 angles, 35 degrees and 90 degrees. You need to solve for the other 2 sides, x and z, and you need to solve for a little angle y down here. But the cool thing is that you could start with any of these, and you could approach it a lot of different ways. So let's talk through a couple different strategies, and I want you to like agree, disagree with each other, offer another way that you can do it. You're really thinking out of the box here rather than just like launching into your one strategy, okay? Okay, so let's take a look. Someone who's already looked at this, can you give us a suggestion of where you would start on the problem? Which one do you want to solve for first? Kevin, eyes on Kevin.
What the z is?
Okay, Kevin says he wants to start with solving for side z. That is absolutely fine. You could have started with something else, but let's start with z. Can someone share with me one way that we could find z given what we already have on the triangle? Kennedy.
You could use cosine.
Cosine of what?
35 degrees.
Equals adjacent 10 over hypotenuse z, and solve for z that way. Okay, you're on the test. That's the way that you're like, ooh, I would solve it that way. And then you look, and that's not what they have. Does that mean what they have is wrong? No. So can someone think of another way to watch out for? What's another way that they could have found z using the 10 and the 35? Christina? We could have also, you should also be thinking in your head, now that we've done a lot of this, you're thinking of all of these ways. Keep a lookout for secant, because that's just hypotenuse over adjacent. You could look for that. That could be another way that you find it, okay? Okay, then you find z. Yay! Z is equal to, does anyone already have it? I know some people started on this.
Oh wait, z?
Yeah.
12.208.
Okay. You find it, you're happy. We know that this is 12.208. Okay, next up, someone else give me a suggestion. Do I want to find the angle or do I want to find x? Lirio, which one do you want to do?
We can find angle y.
Angle y. Okay, what's your strategy for finding angle y?
And like it would be like 180, so then you will add 90 plus 35, and then subtract 35.
Okay, so she says that a triangle adds up to what?
180.
180. And so she knows she already has 90 plus 35 is 125. And if the total needs to be 180, then I can just see what's left. 180 minus 125. Lyria, what do you get?
55.
Someone that already did 55. Cool. So angle y is equal to 55 degrees. I would argue, I like Lyria's strategy, I would argue that's probably the easiest way to find that angle. But do I have to find angles using adding up to 180? What else could I just, you don't have to give me the specifics, but in general, what's another tool we have based off of today to find inverses? I'm going to wait for a few more hands. Got Christina with me. What's another way to find angles on a triangle? I'm going to wait for a few more tables. I got people at Christina's table. I got people back here at Ehong's table. Laz or Diego, are you still with me? What's another way that we could find angles? If you don't see them using 180 like that, what else is another way we could have found that angle? Melanie?
The 90 degrees.
Yeah, you're still using 180 there. So what's another? You're on the lookout because you're like, they didn't do the same thing as me. What else could someone have done to find an angle? Okay, Lirio, everyone else make sure you're listening. Like this table, make sure you're listening because we don't have it.
Since you already found z, you can do opposite over hypotenuse, which is turn. Can find the angle.
Yeah, not tangent. What are we going to use?
Inverse tangent.
inverse tangent of, so like you would need to recognize that this is totally valid, right? To use inverse tangent of the opposite 10 over the,
Wait, it was close
ooh, but that, do we have the adjacent?
There was close line.
Not yet.
The inverse of close line.
Cosine inverse would be the adjacent.
Over
We still don't have the adjacent. So I don't think, for the way we're going, yeah, it'd have to be opposite over hypotenuse. That's why this is tough. It's tough to identify what we could do. Do you guys agree that this would also work? Inverse sine.
Yep.
If I'm trying to find this theta, opposite is 10, hypotenuse is 12.208. If you're trying to find angle y, you could do this as well, right? Cool? Alright. And then, once you have these two, you can find angle x, again doing a lot of different things, but I'm going to allow y'all to go work right now. Side x ends up being 7.002. Sorry, this was z. If you solve that way, okay? Okay, I'm going to pop in with some groups that maybe feel like they need some more help. I'm going to let y'all just work though through these next two and find all the missing things, alright? Go for it. So we didn't solve for that last one yet, but this last exercise. But if you look right here, you could either use like Pythagorean theorem and just say 10 squared plus x squared equals 12.208 squared, right? Pythagorean theorem would work. You could use 35 degrees and say opposite over adjacent and say tangent of 35 degrees equals x over 35 and solve that way. Lots of different ways to solve for that, but that's what we'll get. Okay? Okay, so let's look at the second one. We've got to find both of these angles, A and C are missing. And this side, little c, is missing. Okay? We can start with whatever we want. Any thoughts, any preferences of what we start with? Okay, he says let's start with the side C. Okay? Unfortunately, if you look at your picture, we can't use sine, cosine, or tangent because do we have any of the acute angles? The only angle we have is 90. You can't use the 90-degree angle with sine, cosine, or tangent. So we can't use SOHCAHTOA, but we still can find C because we have the two other sides. If we have the two other sides, we're going to get Pythagorean theorem. Okay? Now be careful because this is not C from Pythagorean theorem. This is just C, a random letter on your triangle. In Pythagorean theorem, C is your hypotenuse, right? So you would have to say C squared plus 20 squared equals 37 squared, and then solve. Okay, so set that up and solve. What are you trying, Melanie? What are you working on first? Which part of it are you trying? Anyway. Okay, so if you're finding A, I agree that's the opposite.
Yeah.
Okay, so if you're finding A, then you're finding angles, so are you going to use an inverse trig function or not for angles?
Oh, that's for the sides.
That's for the side. So now, right now you're finding the angles, you're going to use inverse.
I don't know when to use it. That's the thing I don't get. Like which one to use at which problems.
You have the opposite and the hypotenuse. OH.
Like how you get y and
Oh.
Yeah, you can write on you write it right here.
She went over it, it's not fine.
no y.
So inverse sine. Okay, Stephanie, question?
I don't get this at all.
Oh, you what? Okay, yeah, we didn't.
I don't.
there's a lot of different ways, okay, so now, one way you can think about it is, you're like, oh, I love Pythagorean theorem back in the day. Since you have these two sides, to solve for this one, you could say 10 squared plus x squared equals 4.2 squared. You just solve for x that way. A squared plus c squared equals c squared. So that's one way. Another way is you could say, okay, now that I have all my angles, I could say this is 35, this is my opposite, and that would be adjacent, so I could say tangent of 35 degrees is x over 10, and I multiply times 10.
Opposite.
Same thing that way. You could use this angle down here, which we got was 65 degrees, and you could say this would be the adjacent now, right? And that would be the opposite. So you could use tangent
This was that
55 degrees. And now if you're looking at this, the opposite is 10 and the adjacent is x. Like that. So all of those you'll get the same thing, but you will set know one of the things that works to solve for it. Okay?
My question is, like, I'm not sure, like, how do you know which one to use? How do you know which one you have to use?
Which of these? It depends what you have and what you're solving for, especially in these problems because you're like, depends on which thing you're like committing to starting for. So like because you first, it looks like you were solving first for angle A, okay? So because like you have to like choose that, say okay, I'm trying to find this as my angle theta. Since I'm finding an angle, I know I need an inverse function, okay? And then you're like, okay, now which one do I use? And that's where you're saying you're struggling, okay? So you have to see, okay, what do I have? I don't have this, so I don't have my hypotenuse. So I basically cannot use, uh-oh, it looks like I actually, oh no, I do have my hypotenuse. Sorry, C is my what? So for theta, since you missed this on Friday, the opposite is always across the triangle from theta. So this would be your opposite. The hypotenuse is always across from 90 degrees. So this is your hypotenuse. And this one is your adjacent because it's right next to it, but it's not the hypotenuse. Okay? So we have our opposite and hypotenuse. We can't use anything that has the adjacent because we don't know the adjacent yet. So any of these adjacent things we basically can't use. So we're going to have to use inverse sine because it has the opposite and hypotenuse. And we say inverse sine of 20 and 37 equals this. If we tried to start using,
How do you know which one to use?
so you could have used sine, but you could have also used cosecant.
No, it doesn't.
Does it matter?
Except cosecant is hypotenuse over opposite, so what would go on the top?
Hypotenuse would be 37 or 20.
Okay. If you plug these in your calculator, you'll get the exact same thing.
So it doesn't matter?
Doesn't matter. But could I use, let's say you're like, ooh, I love secant. Let me use secant. You're going to go like this, and then you're going to say hypotenuse 37 over adjacent, oh no, C. I don't have that yet, so I can't use that until I find this side. Okay? So that's how it depends on what you use, depending on what you have and what you're trying to find.
Wait, can you repeat how did you find the theta first?
Theta?
Yeah.
Well, that's what we're solving for.
Oh.
So then you type that in. Now we know theta is equal to 32.720. Okay. Now you need to find angle C and little side C. You can pick whichever one you want.
Okay.
Which one are you going to do next? The side C? Okay. So let's kind of restart. So I'm using pencil because this is going to change depending on what angle and what we're looking at. Okay. If I'm trying to find side C, there's a couple different things I could do. I could either use this angle and now say, oh, this is the adjacent. And then I can use either of those. I just have to commit and figure out which thing to use. Or you can use the fact that you have two sides and use Pythagorean theorem and just do a squared plus b squared equals c squared. Okay, so either one. Let's maybe practice using these since you're like less familiar. So if I have 32.720 degrees, this is my opposite, this is my hypotenuse, this is my adjacent, okay? Let's pick two of them. Do you want to use the 20 or the 37 with the 20? So you have opposite and adjacent.
You can either add this plus this plus that.
Okay, so if you use tangent
use
of 32.720. That should be equal to O 20 over A C. And then you can multiply times C and then divide by all this stuff over here and solve for C. Okay? If you would have chosen to use this one, you would have just had to change because you would have had hypotenuse and adjacent. You would have had to say cosine of 32.720 equals C over hypotenuse 37. And notice like both of them have C that you can solve for. Both of them should give you the same thing to solve. Okay? So it's kind of like you and Kennedy could run two different ways, but you could get the same answer. So when you're checking with each other, don't assume that that's the only way to solve it. You gotta make sure you like understand that any of those work.
Could you potentially use 90 as your theta?
No, because think about if you start labeling your triangle with 90, this becomes your opposite and your hypotenuse when you run into an issue. That's the limitation.
But you could use this one as theta instead of.
Yeah, but then this is going to switch. This is no longer going to be the adjacent. Now this is going to be the opposite. So you just got to relabel your triangle. How are we doing over here?
So this is that angle to top
So this is great. You go to C. You go to so like for these, you're missing solve for any of the missing things. In this case, you're missing C, you're missing angle A, and you're missing angle C. Cool. Okay. Let's check over some of these so that we can use our last few minutes to talk about some word problems. So I'm going to let y'all kind of check what you have so far. If you haven't finished all of these, that's okay. You're welcome to jot down anything for you to finish practicing at home. And then let me know if you have any questions. So for this one, we were missing two angles and then side C. So you should have solved for all three of those things. Here's what you get for your two angles. Here's what you should have gotten for side C. You could have done a number of different things, but no matter what you did, if it was accurate, it should have given you these answers. Okay? Give you about 5 more seconds looking at your answers for that, and I'm going to go on to the next one. Okay, third one, you were solving for R and S, two side lengths, and then one other angle, which ended up being 67 degrees. These were the two side lengths that you should have gotten there. And then always make sure your answer is reasonable. Like for example, which side is the longest side of a right triangle? Notice in my example, is my hypotenuse like the longest side? 35, 38, 14. It's the longest. So like if you have extra time on a test, you're checking your work, things like that, those are things to watch out for to make sure your answers are reasonable. If you got like 2, it's kind of like, that seems fishy. I feel like I should have gotten 2.5 there, right? Like it should have been longer than that. Okay. All right. 2 quick vocab words dealing with some word problems we're going to get to where you're going to set up based off of a situation, a triangle, and have to solve for a distance or an angle or something like that. 2 things I want to talk about are the angle of elevation and the angle of depression. So you don't have this whole sentence in your notes, so I'm going to kind of summarize, and y'all are going to write down what you feel like is important, okay? So the angle of elevation means that if I'm got my line of sight, and my line of sight is like looking straight out in a horizontal line, right? If I look up, the angle between my normal line of sight and looking up above my horizontal line of sight, that is my angle of elevation. So notice this person would normally look forward on this horizontal line, but if they look up at this plane, that angle is what we could describe as the angle of elevation, okay? So if I describe a problem to you and I'm like, Joe is looking at a plane at an angle of elevation of 30 degrees, you can label this as 30 degrees. If the distance from him to the plane is 1,200 feet or something, you could label that, and then we could solve for some other missing information, okay? Okay. The angle of depression is the opposite. If you picture this plane, their line of sight is straight ahead like that, right? If they look down below, that angle from a horizontal line looking down is what we would call the angle of depression. So if there's ever not a picture provided to you, and they're describing in words some sort of situation, you should be drawing something like this for an angle of depression and something like this for an angle of elevation, okay? We're going to do more of these, like I'll keep rolling them in, but for now, let's take a look, I'll give you a few more seconds on this, at this next word problem, which deals with, you'll hear them say the angle of elevation in there. Okay, can I get someone to read right here where it says a ground crew worker on the next problem? And you're going to see one of our vocab words. Go for it, Sandy.
A ground crew worker who is 6 feet tall is directing the plane on the runway. So the worker sights the plane at an angle of elevation of 32 degrees. What is the horizontal distance from the worker?
Okay, so if you look at this picture right here, they have drawn this little person. I know it's hard to see them over here. And they're 6 feet tall. And then they're looking up at this plane. So that's what's describing this angle of elevation right here as 32 degrees. Now, we also see that in the picture, it didn't say this in the paragraph, but in the picture, you see that the distance from the plane all the way to the ground is 150 feet. However, this right triangle does not go all the way to the ground because it's the angle of elevation. The bottom of the triangle is actually up here with like his line of sight, right? So if from the plane to the ground is 150 feet, I need to take out this little piece right there from the ground to his line of sight, which is how tall? 6 feet. So I need to take out this little 6 feet to find my side of a triangle. We could probably do that in our head. If I have 150, take away 6, what's left for that side of the triangle? 144 feet. And now I have a triangle where I'm solving for the bottom, x, the distance between the worker and then we've got 32 and we got 144, okay? So really quickly set up for me in our last few minutes what you would do for that. Independently, try that one independently, set up for me what you would do to find that horizontal distance.
Big tangent.
No.
And the angle, because we're looking for here, right? So then the angle is opposite, and then this is the side
Thanks, Miriam. I can give you one. So the hypotenuse is always across from the 90 degrees. So the adjacent is the side that's not the hypotenuse. The hypotenuse is always that longest side across from the 90 degree. So I agree, they're both touching it, but one's always the special hypotenuse, the other one's the adjacent. Okay. Okay.
Yeah. Cotangent plus hypotenuse, right?
Okay. Someone else to share out in our last minute what trig function they used. Someone share out what trig function they used for this one. Felix. You've got the opposite 144, I agree, but this one is it's right next to it, is the adjacent, right? Opposite and adjacent. So we're going to use tangent or cotangent for this one. Tangent or cotangent for this one. And you should get 230.448 feet using tangent or cotangent. And then make sure you just have units there. So you use sine. So it's just why you're not I will use it though, right?
Oh, in our class, a lot of people did good.
All